Hello everybody, in the last video I finished the classification using Orange. I hope you enjoyed it. In this video I'm going to talk to you about image analysis. So imagine you have a bunch of images and you want to classify them and see what kind of classes do you have. Like, can you classify them, do some predictions on images? Yes, you can in machine learning and also in Orange. So let's first start by opening a file which contains some images, right? I will go over here and I'll use the traffic sign, which is from the Orange dataset, and again it's in my GitHub page. You can just download the repository and you will have everything there. Okay, so I open it up. Now let's view them in an image viewer, right? Good. We have warning signs and regulatory signs. So we want to see if we can classify this, right? Now, if I want to do that, I have to embed my image. What's image embedding? Image embedding is actually taking this and making matrices with features out of them. So you have features and we have labels. Features are going to be your data, for example, 0, 1, 0, 1, whatever. But labels, I want to show you this in it. Oh, I think it will show you. Yes, there you go. It's embedding them in 2047 features, right? So you have features, and this is the category is your label, okay? I don't need to do that anymore. I'll just go directly here, and I will show you something called silhouette plot, which just easily shows you how it's actually classifying them to regularity and warning. Or I can do some hierarchical clustering. This is like an unsupervised learning algorithm. So first you have to just find distances. What is distances? Distances is just basically imagine like a distance between 2 points. When they are too far, make them a cluster, okay? And the ones which are closer to each other, make them one cluster. Like, good to go. And I will just give it to hierarchical clustering, which is a dendrogram. And you see, it already did it, but one issue is this regulatory is not good, so it's fine. It's not bad at all, right, up to now. So this is one example. We did some hierarchical clustering, and I showed you how you can actually, take images and work with them. Now, I'm not gonna go too in depth because it needs a lot of time for running it in Orange. I'll just try to cover the basics so you can do yourself. And also, you can directly import images. I'm gonna throw this one out for now, so we can't do that anymore. We can't take it here in for now. And then let's see what kind of images I want to take in. Okay, let's open. You're just gonna open your file and choose the folder you have your images in and just open. It already took 19 images in. Look at them through image viewer. Let's see. Okay, nice. We have a bunch of animals, dog, horse, and definitely make sure that your images are labeled. I took this from the Orange website, so they are good. And I'm going to embed my images. Again, let's see what embedding does if you want to check. It just takes and makes a bunch of features out here for you. Ooh, you see how many features do we have? 2047 features, right? Now, I'm going to remove this. We don't need it. So I'm going to define, find the distances between these two. Between this, and see if what kind of clusters are coming out of it. Okay, we have clusters. Now let's check this cluster here. Right, this is an important cluster because I'm gonna throw that image back in and test it, see how it works. To do so, I'm just gonna open another image viewer. This is the cool thing about Orange. You can just select data and check it again. So you see these are cows, lambs, sheep. They are close, animals. They are very close. They have close features. Now let's throw Mika in, right? And then just reload this and see what happened again. Select the same group and see, yes, it definitely did it. It even colored and crazy, but it still could understand this is close to these animals. So this is what you can do. You can take images, do classifications, SVM classifications, you name it. Basically, you can do that if you have only two. So let me just show you that by one example again, the same, the traffic sign tab, and I'll connect it. I'm embedding it. I'm gonna connect it to a test and score. Okay, and I'm gonna do a SVM over here, which is the best way of classifying a map. I like this if you don't want to do machine learning. It will take a bit of time to do so, so let's see how good it's gonna do it. And also it gives you the time left for those classifications. And I'm sorry, I'm using my MacBook Air, so you know it's not that fast. Okay, good to go. Classification accuracy is around 92%. That's not that at all. And if I change SVMs, you know, SVM has, you can change the cost, you can change the regression epsilon. These are outside of this video, and you can change your kernel. So basically kernel is either linear, polynomial, and you can do Gaussian, okay? And RBF is the Gaussian and sigmoid function. The Gaussian fits everything, okay? Because it generates infinite number of features, okay? And if you want me to explain this, please, again, write in comments. I'll try to make a video and explain how the SVM works, and I'll try to write down some Python codes for you. So for this video, we are done, and you can check again as many as, you know, even if I don't do this, I think it should be fine. I can even check different learners, like I can say neural networks and give it time because it's a bit slow. It takes time to run. For neural networks, what are neural networks? Basically, you have a bunch of neurons instead of one neuron of SVM. For example, you have a bunch of neurons with softmax, which does the same, which divides the work and give you better accuracy, definitely better accuracy, 95%. So in this video I showed you how you can do image classification and testing. You know, the testing, you're just gonna throw an image and check your model on it. So that's, I hope you know that by now. Do some predictions. In the next video, I'm gonna start talking about text, which in my opinion is much more cooler than image analysis. And as always, enjoy machine learning and shoot comments and your questions, please. See you in the next video.